Now let's see the third question. Find partial derivative of f with respect to x, with respect to y, and with respect to x and y. So here our function is f of xy equal x squared plus xy plus minus y cube. So we have two variables here, right? X and y. So let's see how can we solve them. So partial derivative of x, partial derivative of f with respect to x, it will be 2x plus y. So let me show you here. So as you are doing partial derivative with respect to x, so y will be a constant. So derivative of this constant will be 0. And then derivative of x is 1. So 1 times this constant, that is y. 1 times y is y. And then, so we get y here. We get minus 0 here. And partial derivative of f with respect to x, partial derivative of x squared with respect to x, that is going to be 2x, right? 2x. So 2x plus y, our answer is 2x plus y. So here is 2x plus y. You see here 2x plus y. And then partial derivative with respect to y. So now
Omar, can you repeat?
Yeah, sure.
Can you repeat?
Yeah, sure. So partial derivative with respect to x. So we treat y as a constant. So this is a constant. This y is also a constant. So derivative of a constant is 0. And then derivative of xy. So as y is our constant, so we keep y. And derivative of x, it is 1. So y times 1 is only y. And then plus derivative of x squared, so it is 2x. So that's why partial derivative of f with respect to x, it is 2x plus y. Can you understand?
Why y power 3 equals to 0?
Because we are doing partial derivative with respect to x. That's why this this value here, y cube, we have to treat it as a constant. So derivative of any constant, that is 0.
Okay, because there's no x.
Yeah, right. There is no x.
Okay.
And then partial derivative. And then partial derivative with respect to y. So we treat x as a constant. So this will be 0. And then partial derivative of y is 1. So 1 times x, that is x. And then derivative of minus y cube, so it will be minus 3y squared. So x minus 3y squared. Okay. And then here is a partial derivative of with respect to x and then y. So with respect to x and then y, it will be so we have to firstly find the partial derivative with respect to x. So where is that? That is here, right? 2x plus y. It is with respect to x. And then we have what? Then we have with respect to y. As you see here, then we have with respect to y. So now you come here and then find the partial derivative with respect to y. So this will be a constant. So it will be 0. And then partial derivative with respect to y, it will be 1, right? So ultimately our answer is 1. So that's why the second order partial derivative of these two variable, firstly with respect to x and then with respect to y, it is 1. Is that clear, guys?
Can you explain in the last part?
Yeah, sure. So as we have okay. So we have second order partial derivative with respect to x and y. So firstly we have x and then we have y, right? So that's why you have already calculated partial derivative with respect to x, that is here. And now you only need to consider about partial derivative with respect to y, but you have to calculate from here because this is partial derivative with respect to x. So with respect to y, it will be now this will be our constant because we treat x as a constant, so it will be 0, and then derivative of y, this is 1. So 1 plus 0, that is 1. So that's why second order partial derivative of f with respect to x first and then y, it will be 1.
Okay, Amar, I see.
Is that clear?
Yeah, that's all clear.
Okay. Find partial derivative of z with respect to t. Sorry. Yeah, partial derivative, right? So find partial derivative of z with respect to t if z equal uv square plus cos u, u equal e to the power t, and b equal ln t. So okay, so this is some kind of a implicit function. Okay, implicit function. Because is that really? Uh, okay, let me pause and so this equation, this is a parametric equation because we have the equation that is z equal ut square plus cos u, but again u depends on another variable that is t. So if you look here closely, we have another variable t here, right? So u now depends on t, and we have u here, and then again we have another variable v that is also depending on t. Okay, so we have multiple equation here that depends on the same variable t. That's why this is kind of parametric equation. You can assume that t is some kind of time. Okay, maybe in some real life t is time. So we have so many things that depends on time, like the velocity that also depends on time, and acceleration that also depends on time, right? So that's why we can say t is just another variable. So u and v, they depend on t. So this kind of equation, we call it parametric equation. And then let's see how can we solve them. So first thing first, to solve them, this is the formula. So derivative of d with respect to t. So we firstly we find the partial derivative of z with respect to u times partial derivative of u with respect to t. Then plus partial derivative of z with respect to v times partial derivative of v with respect to t. Okay. So this way, z u t and z v t. Okay. Z u t z v t. So now let's find partial derivative of z with respect to u. So here it is. So if we want to find the partial derivative of z with respect to u, so v will be constant, right? So partial derivative of u will be 1. So 1 multiplies v square, it will be v square. And then derivative of cos u, it will be minus sin u. So let's find partial derivative of z with respect to v. So again, we have to treat now u as a constant. So partial derivative of z with respect to v. So derivative of v square, it will be v. So it will be 2v. Derivative of v square, it will be 2v. And then as u is a constant, so we can just take the constant out, or we can just write down the constant here. So it is 2uv. And then partial derivative of u with respect to t, it is going to be, so with respect to t, right? So partial derivative of u with respect to t. So here, as we have t here, so e to the power t, derivative of e to the power t, it is e to the power t. And then partial derivative of v with respect to t. So here it is ln t, right? So derivative of ln t is equal 1 by t. Guys, is that clear?
Can you explain it again?
Yes, sure. So do you understand this formula? I have just written here partial derivative of z with respect to t. So for parametric equation, we have to solve this way. We have to find the partial derivative this way. Firstly, so partial derivative of z with respect to u. So z u u t, and then z v v t. Okay. So partial derivative of z with respect to u. So we treat b as a constant. So b square will be also a constant. And then derivative of u is, it is 1. So 1 times b square, it is b square. And then derivative of cos u, it is minus sin u. Now let's see how do we find partial derivative of z with respect to v. So now u will be constant. U will be constant. So now u will be constant. So derivative of b square, derivative of b square, it is 2v, right? It is 2v. And then as u is constant, so we keep u where it was. So it is 2uv. And then cosine u, this will be also a constant because we are doing with respect to v. So this is 0. So we can write down 2uv. Okay.
Okay, Omar.
Okay. Now partial derivative of u with respect to t. So here is u equal to e to the power t. So derivative of e to the power t is e to the power t. So here is e to the power t. And then partial derivative of v with respect to t. So derivative of ln t, it is 1 by t. So this way we find the partial derivative of this parametric equation. Is that clear now?
Yes, Omar.
Okay. So now let's see the next part. It is now you have to just substitute the value back. Okay. As we have partial derivative of z with respect to u, that is v square minus sin u. So you write down v square minus sin u here, and then 2uv you write down here, and then e to the power t you write down here, and then 1 by t you write down here. Okay, we just substitute the value in the formula. So we got this function, and then again you have to substitute the value of u and v. Okay, u and v. So here u was e to the power t, right? And v was ln t. So if I substitute here u is equal e to the power t and v equal ln t, so it will be 2 into e to the power t times ln t, right? I just substitute the value, okay? And then we have 1 by t here, right? 1 by t. Okay. And also here we substitute the value of v, and we substitute the value of u. U is e to the power t, right? U is e to the power t. That is given in the question, right? U is equal to e to the power t. So sine e to the power t. And then here b square, that means v equal ln t. So it is ln t square. And then you can just take e to the power t, you can just factor out e to the power t, because here we have e to the power t, and also here we have e to the power t, so we can factor out e to the power t. So e to the power t is factor out, or this is common, and we get ln t square minus sin e to the power t plus 2 by t log t. So is that clear, guys?
Yeah, that's all clear.
Okay, now let's see the fifth question. Find an equation for the plane passing through this point and this 2 point perpendicular to another plane, this plane. So as you see, we have 2 points, right? So we have to find P1 P2. So P1 P2 means P2 minus P1, okay? P1 P2 means P2 minus P1. So on minus 1, that is 0. So here is 0. 2 minus 1, that is 1. Here is 1. And then minus 1 minus 1, that is minus 2, okay? So this way we find P1 P2. And then you have to find the norm vector. So the norm vector is the cross product. So here is ijk. So here our this is our P1 P2. So we write down here P1 P2, and then we have another plane, right? So for this plane, the coefficient of x is 1, coefficient of y is minus 2, and coefficient of z is 3. So this is our another function, uh, another value, okay? So we put it here. So P1 P2 is also a plane, okay? It's not a plane, it's just a point on the plane. So we get another 3 points from here, right? From the plane. So it is 1 minus 2 and then 3. So I just write down here on minus 2 and 3. So now you have to solve this. I hope you can solve this. And then we get the coefficient minus 1, then minus 2, and then minus 1. So this is our norm vector. And the formula is x minus x naught. So a times, okay, let me show you the formula. This is the formula, okay? A times x minus x naught, a times x minus x naught plus b times y minus y naught plus c times z minus z naught equals 0. So I can write down here times x minus x naught b times y minus y naught plus c times z minus z naught equals 0. So here our x naught, y naught, z naught, they are the first point. They are the first point. And a, b, c, they are the coefficient of norm vector. Okay. So you see here. Here the x naught, y naught, z naught, they are the first point. So the first point is here, P1, 1, 1, 1. And then ABC, they are the coefficient of norm vector. So here our coefficient of norm vector is minus 1, minus 2, and minus 1. So that's why here is minus 1, then minus 2, and then minus 1. And then here for x minus x naught, so x naught is 1, y naught is also 1, and z naught is also 1 equals 0 according to the formula. So if we just simplify this, we get x plus 2y plus z equal 4. So this is the plane. So this is the equation for the plane that passing through these 2 points and that is perpendicular to another plane. Yes, can you understand?
Mm, wait, Omar, can you explain about this?
Yeah, sure. So this is just the norm vector, okay? So if can you do this? Can you
Which part?
this part from this part to here?
No.
Okay, so let me show you. Let me
Mm-hmm.
open let me open a new blank page. We have ijk and then we have 0, 1, minus 2. And then we have 1, minus 2, and 3. So firstly, you have to think this way: plus, minus, plus. So if we have more, then it will be this way, like minus, plus, minus. Okay. So as we have only 3, so it is plus, minus, plus. So now, if we take I, firstly we have to consider I. So I is plus, right? So I just write down here I, and then for I, we have to cancel out the row and column. So we get on minus 2 and then minus 2 and 3. And for j is minus, right? J is minus. So we take minus j. So for j, again, we cancel out the row and column for j. So we get 0, minus 2, 1, 3, okay? We get 0, minus 2, 1, and 3. And now we take k. Oh, sorry. Uh, it was 1 minus 2. So now we take k. So k is again plus. So plus k. So for k, we have to cancel out the row and column for k. So we got 0, 1, on minus 2. Okay. So now you have to multiply this way from from left to right, from top to bottom. Okay, this way. Then minus this way. Same thing for here. Multiply this way, then minus this way. Multiply this way, minus this way. So I times 3 multiply 1, that means 3, then minus 4. So 3 minus 4 is minus 1. That's why I can write down here minus I, right? And then for minus j, so 3 multiply 0 is 0, then minus 2 multiply 1, that is 2, that is minus 2. So minus 2 minus minus 2 that is plus 2. So I can write down here 2j, okay? Minus 2j. Guys, is that clear? I mean, I have write down here minus j, and then minus 3 multiplied 0 is 0. Then minus 2 multiply 1.
Yes, Omar, I
So
got it.
that is minus 2. So that is minus becomes plus. So plus 2. And plus 2 times minus j. That is minus 2j. And now plus k. So it is again, if you just multiply, so 0 multiply minus 2 is 0, then minus 1. So that is ultimately minus k. So minus I, minus 2j, minus k. You see here minus I, minus 2j, minus k. Okay. So this way we solve this kind of matrix, or this is called cross product. Okay. Because in our high school we learned vector cross product, right? So this way we also find the cross product of two different vectors. If one vector is 0, 1, minus 2, and another vector is 1, minus 3, 1, minus 2, 3, then their cross product will be this one, minus I, minus 2j, minus k. Okay? So this is very important theory just to learn. So let's continue, okay? So we have just put the value in the general form. Is that one clear? We have just substitute the value in the general form. Okay.
X0, where can we find that?
X0, X0, Y0, Z0. That means X0, Y0, Z0. Yeah, they are the first point here. They are the first point. So here you see, X0 is 1, Y0 is 1, and Z0 is also 1.
Okay.
And then ABC, they are the norm vector, the coefficient of norm vector. So here is our norm vector. It is minus 1, it is A, and minus 2, this is B, and minus 1, that is C, okay? A, B, and C. Can you see here minus 1?
Okay, I get it.
Minus 2, and then minus 1. We just substitute the value in this general form.
Okay, I get it.
And then simplify, we got x plus 2y plus z equal 4. After holding the mouse for a long time, I'm facing some hand pain in my finger. I'm facing finger pain. So let's see the next question, number 6. Calculate partial. Okay, so this is a double integral, right? So find double integral of this function. So here our function is x plus y plus 1. But so the first one here, the boundary for x is minus 1 to 1, and boundary for y is minus 1 to 0. So as you see, firstly, they have written here. So the boundary for x, that is minus 1 to 1, right? As you see here, minus 1 to 1. So dx, and then boundary for y is minus 1 to 0. So minus 1 to 0. And for y, this is the function x plus y plus 1. Because we write down the function at the last part, okay? We write down the function at the last portion, not with the first portion. Because as this is y, so we have to integrate y first, and then we have to integrate
Omar, is it the same with in the first part in number 5?
Yeah, the same way, right? The same way. But the notation is
okay. We can solve it in the same way.
Yeah, right. The notation is just little different, but if you just write down this dx on the last, then the notation is same as before.
Okay, is that okay, right?
Yeah, right.
If I solve it with the way in the number 5.
Yeah, you can just do that.
Okay.
But still, we can just have a look. Okay, the partial derivative with respect to y. So it will be 1. Sorry, this is not derivative. This is integral. So integration of y, it will be y square by 2, right? So here, that's why I have
Yep.
written here y square by 2. And then with x we have 1. With x we have 1. So integration of 1, that is y. So y times x, that is xy. And again here, integration of 1, that is y. So only y here. And then we have written here the boundaries, -1 to 0. And next we have to put the upper limit and lower limit. I mean, we have to just put substitute the boundary here. So, but as we are doing with respect to y, so we only need to replace y. So here x times 0, it is 0, and then half times 0 square, also 0, and then plus 0, that's 0, and then we have to substitute the lower limit. So minus the lower limit. So -1 times x is -x, and then -1 in a square is on. So on by 2 is half. So plus half. And then minus, we substitute here -1. So again here we have -1. Yeah. X plus half. Okay, so now see, we have a minus on the according to the formula. Do you remember in the first semester we learned how do we calculate the definite integrals? So this minus is from there. We put the upper limit. So if we put upper limit, so upper limit is 0. So all those things become 0. Then this minus is from the formula. Then we put a lower limit. So if we put a lower limit, so we get -x plus half minus 1. So if we just multiply this minus inside, so it will become x minus half, then plus 1. So it will be x plus half. Is that clear? Okay. And then we are left with x plus half. Now we have to we have to integrate x plus half with respect to x. So x plus half with respect to x, that is going to be okay. So derivative of integration of x is x square by 2, and then integration of half, this is gonna be x by 2, because with half we have only 1. So any integration of any constant, that is constant times that function. I mean that x or that y. So now we have to substitute back the boundaries. I mean the upper limit. So here is 1. So 1 is square, that means 1. That means half. Then plus half. This is the upper limit, and then minus. The lower limit is -1. So it is gonna be minus half, then minus half, right? So half plus half is 1, then minus half is -1. So -1 minus 1, that is 2, right? Oh, sorry. Minus half, that is 2, and then yeah, -2. So 1 minus 1. It should be 0, but why it should be 2 or 1. Half into 1 square, half plus